This is a review of quiz number 2. You're going to need your formula sheet to help you do these problems. So for the first one, it's asking us to simplify. Secant squared of negative x minus tangent squared of negative x. Now whenever you have a negative x in the parentheses like this, they're referring to the even and odd identities. Now, all the even and odd identities, they are not squared. That's because when something is squared, we already know that the negative goes away. So the negative inside the parentheses is going to go away, so secant squared of negative x just becomes secant squared of x minus tangent squared of negative x. Well, since it's squared, the negative inside the parentheses goes away, and you just get tangent squared of x. Secant squared x minus tangent squared x, that's a Pythagorean identity. That's right here. It equals 1. So the first problem just simplifies to 1. Now the next problem has sine of x. That one's fine. We have secant of negative x. Well, when the negative x is in parentheses, it's an even and odd identity. So we have secant of negative x equals secant x. So the negative goes away for secant. For cotangent of negative x, the negative moves to the front and it becomes negative cotangent x. So there was no negative x with the sign, so we're just going to bring that down. And then these three are being multiplied by each other in the original problem, so I just moved down the multiplication signs. Now we're going to rewrite everything in terms of sine and cosine. So sine x is already in terms of sine and cosine. Secant x, we can use the reciprocal identities to change secant x to 1 over cosine x. And cotangent x can either change to 1 over tangent or cosine over sine. We don't want to use cotangent equals 1 over tangent because that's not writing it in terms of sine and cosine. We want to use those quotient identities. So a negative cotangent would change to a negative cosine over sine. Now if you remember that when you have something that is being multiplied at the top and the bottom, you can cross those out. So I have a sine at the top and the bottom and a cosine at the top and the bottom. And all that's left is a 1 and a negative sign. So this becomes a negative 1 as our answer. Now for number 3, it's telling me that theta is in the first quadrant. So quadrant 1 is right here. We're going to draw the triangle just like it's drawn on our formula sheet. Now hopefully you have it written in on your formula sheet that this is the adjacent side and it's positive, this is the opposite side, it's positive, and this is the hypotenuse, and that's also positive because everything in the first quadrant is positive. The next bit of information it tells us is that tangent theta equals to 3 over 4. Now from SOHCAHTOA we know that tangent is opposite over adjacent. So I know my opposite side is a 3 and my adjacent side is a 4. So I'm going to use the Pythagorean theorem to plug in my opposite and adjacent sides to find my hypotenuse. So my hypotenuse is 5. The next step in this problem It says to find the value of cosine pi over 2 minus theta. That is a co-function identity. Cosine of pi over 2 minus theta is the second one, and it equals sine of x. So I'm really trying to find the sine of x. Now we know from SOHCAHTOA that sine is opposite over hypotenuse. So the opposite of this triangle is 3, and we found the hypotenuse to be 5. So your answer is that sine of x equals 3 over 5. Now for number 4, it tells us that cosine theta is 2 over 5. Cosine from the ca in SOHCAHTOA is adjacent over hypotenuse. And that fraction is positive. So we have a cosine is positive. Then it tells us that sine theta is less than 0. When something is less than 0, that means that it is negative. So in what quadrant is cosine positive and sine negative? So we can go through our quadrants right here. Well, everything's positive in the first quadrant, so that doesn't work because one of the conditions is that sine is negative. Quadrant 2 also doesn't work because it says here that sine is positive, but we want sine to be negative. Quadrant 3 also does not work because only tangent and cotangent are positive, but one of our conditions is that cosine is positive. So we go to the fourth quadrant, it says cosine is positive, and we know that all the rest are negative, so sine is negative. Both conditions are fulfilled if we draw it in the fourth quadrant. So if you copy the stuff down from your fourth quadrant here, you should have written down that adjacent is going to be positive, the opposite side will be negative, and the hypotenuse is always positive. We will fill in that the adjacent side is 2 and the hypotenuse is 5. We need to use the Pythagorean theorem to figure out what the opposite side is. So we have our adjacent side is 2. We don't know what the opposite side is, and the hypotenuse is 5. We are going to subtract 4, and you get b squared is 21. And when you take the square root, there is no square root of 21 that isn't a decimal, so just leave it as the square root of 21. And make sure you have that negative sign, just like it has on our formula sheet here. The problem tells me to find the tangent of pi over 2 minus theta. So look in your co-function identities. Pi over 2 minus theta is the one up from the bottom one. So I'm really trying to find cotangent of x, or theta. It doesn't matter what you want to call it. Now cotangent is adjacent over adjacent over opposite. So cotangent x equals my adjacent side, which is 2, over my opposite side, which is negative square root of 21. Moving on to the back, these are all of our solving problems. So for these, you're going to need your unit circle, which is on the back of your formula sheet there. So for the first problem, I have tangent squared x equals 3. Well, I need to get rid of the square, so I'm going to take the square root of both sides, and you get tangent x equals the square root of 3. Now don't forget that when you take the square root of both sides, or a little shortcut here is if you see a square, that means your answer needs to have a plus or a minus, okay? So I'm going to be looking on my unit circle for where tangent, those are the ones in the boxes, where do the boxes equal positive or negative square root of 3? Well, there, which is at pi over 3. Also here, which is at 2 pi over 3. Here is at 4 pi over 3, and this one's at 5 pi over 3. So there's 4 answers for this problem. We have all the pi over 3, so pi over 3, we said 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now for the next one, we need to get the cosine by itself. So I'm going to be adding 1 to both sides. Then I need to divide by 4. Now I need to get rid of that square, so I'm going to square root both sides. So I need to square root 1, which is 1, and then I'm going to square root 4, which is 2. So cosine x equals 1 over 2. But don't forget that since we had this little square, my answer needs to be a positive or negative. Now hopefully you remember that cosine x is the x coordinate. So I'm going to be looking for where is the x coordinate positive or negative a half? Well, here's the x coordinate, it's a half. That's at pi over 3. Here's an x coordinate that's a negative a half, that's at 2 pi over 3. Another one at 4 pi over 3 and 5 pi over 3. So this also has 4 answers. All the pi's over 3's. Now the next problem has a cosecant x, and we want to try to get that by itself, okay? So I'm going to be subtracting 2 from both sides. Then I'm going to be dividing by 4. Now there is not a cosecant on my unit circle. Let me see if I can get some more light in here for you. Alright, so I want cosecant x equals 2. There's not cosecants on my unit circle. So instead, I need to look at what is the reciprocal of cosecant. It is 1 over sine. So the reciprocal of cosecant, it's sine of x. And what's the reciprocal of 2? That means I need to do 2 over 1, and then I need to flip it, so it's 1/2. Now looking at this problem, why is it not plus or minus a half? Well, it does not have a squared anywhere in the problem, so it's just going to be a 1/2 here, a positive a half. So if I look on the back at my unit circle, I'm looking for where is the sine, where is the y coordinate, a positive a half. So that occurs right here at pi over 6, and right here at 5 pi over 6. we're gonna tackle the next one just about the same way. We're gonna try to get secant by itself. So I'm going to be adding 2 to both sides. Then I'm gonna have to divide by the square root of 3. So I have secant x equals 2 over square root 3. Secant is not one of the things on my unit circle. I only have sines, cosines, and tangents. So I'm going to look for the reciprocal of secant. The reciprocal of secant is cosine. So my secant is going to change to be a cosine x. And because I flipped this side, I need to also flip the other side. So it's going to be square root 3 over 2. It is not plus or minus the square root 3 over 2 because the secant is not squared. Okay, so I need to find where cosine x, which is the x coordinate, where is cosine x equal to square root 3 over 2? So where's the x coordinate square root 3 over 2? That occurs at pi over 6 and 11 pi over 6. Great. Now for number 9, you need to do GCF factoring. Now for GCF factoring, we look that we have 2 parts before and after the minus sign. What do those 2 parts have in common? Well, they both have sine of x, so that goes in the front. So I'm in essence taking the sine x and I'm moving it to the front. Everything canceled in that first part, so it leaves me with 1. And the second part leaves me with 2 cosine x. Now when you have 2 things that are multiplied and they're equal to 0, that means that we can use the zero product property to split it up and have each part equal to 0. So this means that sine x is going to be equal to 0 and 1 minus 2 cosine x equals 0. So for this first one, sine is my y coordinate. Where does the y coordinate equal 0? That's at 0 and pi. Now we have to do the other side. We're going to subtract 1 from both sides. Divide by -2. -1 over -2 makes a positive 1 over 2. And cosine is the x coordinate. Where is the x coordinate equal to 1/2? The x coordinate equal to 1/2, there's 1 at pi over 3. And down here at 5 pi over 3. So you have 4 answers. You have 0 pi, pi over 3, and 5 pi over 3. Now the last one is already factored for you. I have things that are being multiplied together that equals 0. So I'm going to split it up and have each part equal to 0. So I have cosecant x plus 2 equals 0 and sine x plus 1 equals 0. And we're going to solve them separately. So I'm going to subtract 2 on both sides. I get cosecant x equals -2. And once again, cosecant is not on the unit circle. So what's the reciprocal of cosecant? It is sine. And if you don't know that, it's located on the formula page right here. Cosecant becomes sine. And then I have to flip a -2. Secretly under a -2 is a 1. So we're going to flip it and we get a -1/2. Sine is our y-coordinate. Where is our y-coordinate? -1/2. That's at 7 pi over 6 and 11 pi over 6. So those are 2 answers for us. And then this side, I'm going to subtract 1 on each side. I get sine x is -1. Again, sine is our y-coordinate. So where is our y-coordinate equal to -1? That's at 3 pi over 2. So this last problem has 3 answers. 7 pi over 6, 11 pi over 6, and 3 pi over 2.